Hey there. In this video, we're going to look at how you can write the three primary trig ratios, exact values, for any angle in standard position given only a point on its terminal arm.
All right, in this first example, we have that the terminal arm of an angle in standard position passes through this point -3, 4, and what we're looking for is the three trig ratios, sine, cosine, and tangent. Now, to start working on finding those, we're going to draw a diagram of the angle in standard position. And so the point -3, 4, -3, 4 is going to be, we'll just roughly put it right there. We don't need to set up a grid or anything. And our angle in standard position, the initial arm is going to be there along the positive x-axis, and the angle rotates that way, counterclockwise, and our terminal arm goes through that point. And since we have these two coordinates, we can draw this little reference triangle on here and then label it with -3. There's the x-coordinate and 4 as the y-coordinate. And then, of course, that's our angle theta in standard position. So to write the ratios, we can actually write one of them with just the values that we have already without finding anything else, and that is the tangent ratio, because tangent is y over x in our circular definition. And so if we write tangent of theta is y over x, we have that it's 4 over -3. I can write it like that, or I can just say it's -4/3, right? For the other two ratios, namely sine and cosine, we're going to need to find the radius, this distance right there, and to do that, we can use the Pythagorean relation. So we can write r squared is 3 squared plus 4 squared. Now, I just wrote 3 here, even though this is -3. You could write -3 if you want. You could write -3 squared there, but when you're squaring it, it's not going to matter if it's positive or negative, so we might as well just keep it simple and write 3 squared plus 4 squared, or in other words, 9 plus 16, 25. If r squared is 25, then r is plus or minus 5. But since r, the radius here, is always positive, we know it's positive 5, so we can ignore that and just say radius is 5. If the radius is 5, right, this value here is 5, then we can write our other two ratios there. So for sine, we have sine is y over r. So we have y is 4 and r is 5. So we got 4 over 5. And then our third one, the circular definition for cosine is x over r. So -3 over our radius of 5 there. -3 over 5. And that's our three ratios. And before we move on, we can just confirm one more thing based on what we know about trig ratios in each of the quadrants. We're in quadrant 2 here, and in quadrant 2 we know that sine is the positive one, the one that's positive, and the other two are the ones that are negative, which is what we've got here, so that is good. All right, let's do one more. In this one we're looking for an angle as well in standard position, this time passing through this point to -5. And so we're going to draw a diagram just the same way. 2, -5 is going to be in quadrant 4 down here. And so our angle, again, starts there, goes around like this, and is going to have its terminal arm right there. Right, so that's theta. And we can, again, draw that little reference triangle and put our values there, 2 for x, -5 for y. And we can write the three ratios. Again, tangent is one that we can find first because we don't need to find that radius. Tangent of theta is going to be y over x, -5 over 2. And if we find the radius, we can write the other two. The radius, again, radius squared is 2 squared plus 5 squared, or in other words, 4 plus 25. Or in other words, 29. Now that's not a perfect square. So before you start grabbing for your calculator, we do want exact values here. And for an exact value, how we're going to write this is we're going to say the radius is root 29, square root of 29. If we wrote it as a decimal, we would have to say it's roughly equal to something, and then it's not an exact value anymore. So if it's root 29, we can say it's equal to that exactly, and we can write the fractions with that in it. So for sine, we're going to have here that we have, from this angle, we've got y is -5, and the radius is root 29, so we can put that on the bottom. We're just going to write it like that. And then our cosine is going to be x over the radius, so 2 over root 29. And you can confirm that it matches what you expect. We're in quadrant 4, and in quadrant 4, our cosine's positive, which is what we've got here, and our tangent and sine are negative. And one last thing is, you might see this written a slightly different way. Maybe you've done some work with radicals before, and if you have, you might see that that can also be written as 5 root 29 over 29, and this one can be written as 2 root 29 over 29. They're exactly the same. It doesn't matter so much which way you write it, but if you're looking for answers in an answer key or something and you see that it's written this way, those are indeed equal. If you haven't seen that before and you want to know how to change them, it's quite easy. Say, for example, that one, 2 over root 29, to get it to have a rational denominator. In other words, not have a square root irrational number in the denominator. To rationalize the denominator, you can multiply it by root 29 over root 29, because that's essentially multiplying it by 1. You haven't changed anything, but root 29 times root 29 on the bottom is 29. And on the top, you end up with 2 root 29. So it doesn't always matter whether you write it like that, and often this is fine, but if you're trying to match it up with something else, you need to know that. All right, that's it.